Hello, hi, and welcome to this data journey from the good old traditional data warehouses to the modern data platforms. So we're going to be talking today about the data lakehouse. We're going to be talking about the data delta lake and traditional data lakes. So quite a lot of ground to cover today. But first of all, thank you. Thanks for joining in. Thanks for tuning to this session. But more importantly, thanks for tuning to the Singularity Tech Day. We all know how challenging this year has been, and we are really dying to see you face to face in the future sessions. But for now, this will have to do. And with all these restrictions and with all these limitations, this year more than ever, our sponsors have been really important. So big, massive thanks to them. But now, without further ado, let me introduce myself. My name is Pablo Doval. I am one of the principal data architects at Plain Concepts, and I am also your host today. I have quite a bit of experience building data lakes, building data platforms in cloud, almost 10 years already. So definitely I have a few stories to share. So let's start for that. So first of all, why we are talking about this, why we are talking about data platforms? Well, the reason is very simple. We are all being asked right now to implement super exciting projects, AI and innovation, to do more with our data. And we all have been working on this for the last couple of years. We have massive stories to share about very interesting models that we can use to extract clauses in contracts and detect anomalies and outliers, or to analyze video and try to detect when an advertisement is running and which specific version of the content is being provided. Or we can use these super smart models for customer segmentation and population segmentation. So we have incredible projects and we have the desire to do so. But to tackle these projects, we need something first, and that's data. And not any form of data. We need to have data that's curated, that's available, that we can rely on, that enables us to use it properly without a huge investment. So we really need to worry about our data state, and we need to worry about how to serve this data and how to make it in a way that it's compliant and secure. So there's a lot of requirements around that. And this is critical. This is really critical. We are in a situation where we face a lot of customer requirements, and probably you in your companies, you face a lot of internal department requirements to engage in some projects, and you are dying to engage in those projects because they are really interesting. They can provide a lot of value to the firm. But we cannot, because either we do a POC, but then we cannot put it on production because of infrastructure or technical challenges, or because the solution is not compliant or fully enterprise ready. So there's a lot of challenge we need to sort out in order to have this data state accessible and allowing for rapid prototyping and rapid move into production. And that's a little bit what we are going to be talking today. So we have evolved and we have transformed and we have done it in a huge way over the last decades. And if you look at the systems you work with, and if you look at your peers, you will see that we have changed, all of us, the systems, us as persons. So definitely a dramatic change over the last decade. So if we look into the data systems, you will see that yes, we might have worked with terminals in the past, and now we might be working with more rich versions of the interfaces. But in the end, most of our line of business applications, they are still transactional, and they still hold data in a tabular way. And even in the case that we have a lot of data that's not tabular, that we're talking about maybe video, audio, or we are talking about sensor data, yes, we have the data, but it lives in silos, and it's very difficult to access this data and enable business case based on these data sets. And lastly, I would like to mention that this all leads to reactive scenarios, which is what we see in most of the companies we work with. So by reactive, what I mean is that we may have a specific business journey. So for example, in this case, a law firm that receives the input from the intake platform from their claimants on a case, and they only act traditionally once the customer issue has been solved or not solved, but in a reactive way, that's where we drive the analytics. And where we want to move to is this picture. We want to have analytics and automation and AI through all potential processes through the company, irrespective of the originator, irrespective of the system. So we have a lot of challenges for this. We have challenges in how we work and with which kind of data, because we need to work similarly. If the data is tabular, if the data is coming from a relational database or is coming from a CSV or from an Excel spreadsheet, yes, there are some of those. Or if it comes from video feeds, or if it's coming from sensor data from IoT devices. So we need to find some way of working in the same fashion, with the same compliancy regulatory frameworks, with the same mechanisms and accelerators. But we also need to make sure that we can support the advanced analytics, whether it's by traditional BI or whether it's by data exploratory analysis with machine learning notebooks or whatever, but through the lifetime of the systems. And that means going even to an event-based approach, not just working on the data that we have at rest on our systems and our platforms, but also the data that's, so to say, on the wire, so reacting to transactions. We need to be able to provide that. We need to be able to provide some sort of rapid prototyping, and I've already spoke about this before. We need to make sure that if we want to create a new system, test a hypothesis, we can do it quickly, in a proof of concept manner. But if that's successful, we want to make able to put this into production extremely quickly and make sure that we do it in a way that it doesn't jeopardize our security standards, compliance standards, etc. We also need to tackle the challenges of working with data dispersal. So a lot of the companies we work with, they have been part at some point or the other of mergers and acquisitions. Say that they bought other smaller firms or they have been acquired, and that leads to having disparate systems, disparate vendors, and that's a challenge. And that's in enterprise solutions, that's a very, very common challenge. So the solution we need to implement needs to deal with that problem also in one way or another, and we will talk about that later. And also we have the challenge that we don't have really a common semantic model in terms of data mastering, but also in terms of traditional BI. What is defined as a specific formula as revenue for finance team, maybe it's not exactly the same way as revenue is computed in operations team or in marketing team. So we need a way to make sure that we can create this common semantic model across the companies and organizations. So definitely not easy to solve challenges. And the bad news is that I'm not going to solve all of them in these slides. I'm going to give a lot of food for thought, but we still need, I would say, a little bit of additional innovation for some of the challenges. But the good thing is that this innovation is coming and coming very quickly and very strong. So let's talk a little bit about data history first. I want to tackle during the next minutes something that's a little bit of a pet peeve of me, which is the difference between a data lake, a data mart, data warehouse, etc. So let's go for it. First of all, let's talk about how this was in the beginning. As I mentioned in the past, we need semantic models because we have a lot of data. We have data from different providers, different nature of data, and we want to make sure that all this data is really usable for all the company. And the way to do that is creating some sort of semantics on top of it. This is way, and probably the first approach, was creating silos of not just of the information, because that's the data as we have it, but also silos for the usage of this information. So the finance department maybe needs just data from the transactional and the marketplace data, and bring all together into a set of reports that they create, curate, and maintain. Maybe we have the same thing for marketing, operations, and HR. And obviously, this works partially well because this allows these teams to operate on the data, to do the transformations they need. But I'm sure you all see the problems with this, and there's a lot of them. Just to summarize a few of the most important thems, is the fact that all the departments will be requiring some sort of technical skills to do the transformation of the data modeling, and the reporting itself that requires some transformations and that requires some specific knowledge. Secondly, and this is probably one of the most important ones, allowing each of the departments to create their own reports and to create their own semantic models. Means that they can create their own formulas for revenue, for efficiency, for utilization, capacity. And again, we know that this might lead to problems when the formula used by one team is not exactly the same as the one used for other teams, and then the reports don't match. So we all have lived these scenarios, right? I'm sure you do. Then we also have the challenge of tracking the lineage management. How do I know if I need to change something in one of the data sources because the provider changed, because the data format has changed, an upgrade of a different version? How do I know that that has changed, and how do I know which different reports this will impact to reach these teams to make them do the required changes? That's a challenge as well in itself. And then obviously there's a balance here between the cost and data governance. This is going to be probably less costly than the next solution we're going to be presenting. Well, without a doubt, it's going to be less costly. But we are losing governance. So that's the trade-off we have here. So to solve these problems, 3 days ago, probably a little bit more than that, Mighty Data Warehouse comes into picture. So we have the data warehouse, and the data warehouse in essence is a good thing. The idea is modeling everything as one single version of truth, and modeling it so following a set of rules. So we have mostly two kind of modeling approaches to data warehouse: the dimensional Kimball approach and the transactional Inmon approach. There is other things like data vault, etc. But there is a set of modeling techniques and approaches and a standardization of what a model should look like. And the idea is we bring all the data from the different providers into the data warehouse. And this enables the different departments to build just the reports, but based on a single semantic model. And the idea is brilliant. The idea is fantastic. The idea is great because most of the work happens at the data warehouse level, so we can have a team fully dedicated to working on the data warehouse level. But at the same time, this creates a lot of challenges. First of all, they are huge projects. They are normally multi-year projects, extremely costly. They normally tend not to never finish because they are so long and so complex that the business evolves and moves with the projects. So by the end, the projects should have finished. There's an addition to accommodate to the changes to the data sources. And one of the biggest challenges here is that since the model is just one single version of truth, if I change something like the invoice related tables and the invoice related dimensions, that means that these changes needed to be propagated through all departments. It's going to impact more places. It's going to impact marketing, operations, etc. So normally maintaining a data warehouse is way more costly than maintaining the other approach, which obviously this is not to justify the other approach, the previous approach obviously, but there is a huge increase on cost and complexity here. In addition to that, even though they have their benefits and their advantages, data warehouses, and they are by no means dead, they are lacking some of the things that we require for modern platforms, like multimodal support. That they don't really work with streaming video, audio, ML, so there are some challenges there as well. But we learned some lessons, and we decided to go through the next iteration, which is the data mart approach. And data marts are a simplification of the data warehouse. Instead of trying to build a single data warehouse, we're going to build mini data warehouses with their own semantic models that are going to isolate the changes and the impact of updating or evolving anything on the model from the other data marts. In this example, we will have a data mart for finance, we will have a data mart for operations, and maybe some changes that happen to the raw data coming from the transactional systems might require changing the finance data mart, but leave the operations data mart alone. and the opposite might happen as well. So this allows us a level of decoupling that works really well. So they are a good addition, they are a good approach. We are still using data marts quite a lot, and actually we use data marts in conjunction with data lakes, so that again they are by no means dead, but they still have challenges. One of them is mastering data. All mastering data exercises are complex by its own nature, but mastering data when you have different data warehouses or data marts, it's a bigger challenge than if you have one single point of truth. So again, not an ideal scenario. Enter the new world, and in the new world we have a lot of additional requirements that we didn't have when we were working with data marts and data warehouses. First of all, we're working with highly volatile data structures. And what that means is that now we cannot just rely on having this entity, and this entity is going to stay the same through the life of the project. This might well happen, and with some exceptions, in systems like CRMs or ERPs, because we have control of them. But when we are working with data from devices, which are prone to manufacture firmware updates, or we are working with data coming from APIs from external systems, that they are constantly releasing updates that normally change the data that they serve us, that's definitely not going to work well for data warehouse, because we are going to have to change our ETL processes. We're going to have to change our consolidation projects, and this, depending on the architecture we have implemented, will have a cascading effect on the semantic model and on the reports. So a huge challenge there. We also have another challenge, which is what we do with real-time data, because now we need to react to real-time data. And yes, we can always implement a Lambda architecture, which is an architecture that, and this is going to be a massive simplification, but basically separates the real-time streaming into one real-time piece that feeds our real-time dashboards and our real-time alarms and our real-time systems, and a consolidation stream that gets consolidated into the data warehouse, ideally into the data lake, as we will see later. So we can work around the data warehouse a bit, but it's still not a good fit for real-time data. Also, the fact that we are now working in hybrid systems and multi-vendor with different providers, and many times even multi-cloud. So that doesn't really apply well to data warehouses, because even though some data warehouse can scale horizontally, they need to be on the same premises or in the same cloud, etc. So that limits a little bit as well our options there. And lastly, but not least, the AI and machine learning capabilities. So they do really require a different set of functionality. And we are talking here about what we do with the version of the training data that we have used to train the models, what we do with the requirements of having the training data of machine learning models in the specific geographic region where that data needs to be, and keeping track of all the history. That really doesn't apply to data warehousing kind of approach. So we have new requirements, and for these new requirements, during this session, so you already know about data lakes. Data lakes were created, and again, they are not anything new. I told you at the beginning of the session, I have been working on data lake projects for probably the last 7 years, 8 years. So by no means new stuff, but we are still evolving them a lot, and we are still changing our understanding of modern data platforms based on data lakes. And again, that's going to be the core for the session today. So first of all, let's talk about the promise of the data lake. I think you all have seen this already, or if you have read a little bit about data lakes or have seen some presentations, the promise is very simple. I have my data, all the data in the company. I just collect everything, and I'm going to use this data to just feed my glorified storage, the data lake. So I store all the data there, and then as the requirements come, I start extracting the value from this data, building my models for IoT projects, for dashboarding and business intelligence, or for exploratory data analysis, or just single-use machine learning models, whatever. And this is the promise of the data lake, and this is what we try to achieve. The premise is storage is extremely cheap. So let's just store everything in a single place and let's access. But obviously, the moment you start working on these kind of projects, you start realizing that the story is not so simple. We have a lot of requirements in terms of compliancy, how I'm going to be cataloging my data, how I'm going to be establishing retention periods, how I'm going to be enabling the compliance requirements such as the right to be forgotten, to delete data on the data lake and to delete it on the business cases that use this data. There's a lot of challenges with taking care of data lake, and a lot of data lake projects. I'm not going to say that they have failed, because honestly, I don't think I've seen any data lake project failing, but probably they failed to deliver what they should have delivered. Many of them, because of the belief in this glorified centralized storage repository. But there's way more to it. So all the years having helping our customers, both with our data platform and our professional services, sorting out these problems, this is what I plan to put today on the table and to discuss with you. So first of all, let's start with what a data lake is not. A data lake is not just a storage. It's not this glorified storage I was talking about. It's not your S3 repository. It's not your Azure Data Lake Storage Generation 2. And the same way, it is not just storage. It is not just computation. You cannot say I have a data lake just because you have a Hadoop cluster or an Spark cluster or an HPC cluster. And more importantly, a data lake is not just a data warehouse. Don't expect to build a data lake and just connect your Power BI, ClickView, Tableau, and have this as a single point of truth, because that is not a data lake. Let's talk a little bit about what is a data lake, and let me make a disclaimer here. For the next slides, what I'm going to be presenting is how we tackle data lake designs and implementations, and a little bit of our lessons learned, what worked, what didn't work, and I'm going to present it based on our product. So we have developed a data platform, which is Sidra. So I'm going to be using Sidra as an excuse to explain a modern data platform. This is not by any means a sales pitch, and actually I'm going to be sharing with you, again, things that didn't work as well as we thought they should be working. But I think it's the best way of sharing my experience with you. We have more than 15 customers already using this platform, so we know again what are the pain points and how to build these solutions, both by the product itself and the professional services. So with that disclaimer out of the way, let us now go back to the presentation, and let's talk about one example of a data lake. I'm going to be talking about how we built Sidra and what design decisions we took. First of all, let me start with the classification. What kind of data lake it is? Well, Sidra, we started building it more than 5 years ago. When we built it, we purposely implemented it as what's called an immutable data lake. So what's an immutable data lake? If we go back to the genesis of data lakes, we have to go to one very famous pivotal paper by Pentaho, in which they described the modern data architectures for data lakes. And in that paper, you can see that they call these systems immutable systems. And that means that if I bring into the system an entity, and the entity needs to be transformed because it needs to be cleaned up, or there's some business transformations we need to transform, we need to create another table because we cannot edit or amend this original table. That was done for two reasons, basically. One of them we can call governance, which is, and it's true that if I am forced to move through to keep all the versions of the data as I am moving through the transformations, I have a very good audit trail, and that's fantastic for auditing. But let's be honest, there was also a technical reason for that. Back then, there was no options for an operational data lake. There was no options for amending data. An HDFS file, irrespective of the format back then, could not be edited or amended. You can just append data, but you couldn't delete or update data. So based on that limitation, all the data lakes were immutable. We're still partially immutable. By concept, we want to make copies of the data because of the audit trail and the tranquility it provides from a governance point of view, especially considering the cheapness of the storage. But at the same time, we are actually using some new technologies, some new formats, specifically Delta, to be able to make transformations on top of the data. But we do it on a special way. We will talk about that a little bit later. So that was important, the concept of Sidra, or of the data lake, as an immutable data lake. There are also operational data lakes, which work almost on an acid way. For me, or for our approach, we think that's missing the point of what the data lake needs to be. If it's going to be operational, that needs to happen in a separate layer, in the business transformation layer. But just to complete the taxonomy there. So when we built Sidra, we had a set of tenants, things that were kind of written in stone. First of all, the infrastructure needed to be, first of all, modular, extremely modular, needed to be created automatically on installation time, but also on once the system is running. So for example, if I want to create a new data storage region and have my data in Germany, because we need to have data for compliance reasons that doesn't leave the country, I want that to be configuration and the system to deploy everything on cloud. Same thing happens with all the different components, up to the connection to the data sources. Everything is automatically created by the system. And we think that's important, and we think that mix with modular approach is really important, and that's one of the suggestions, the first suggestions I'm going to make to anyone building their own data platforms, which is decouple everything, make everything modular. Let me explain this with a couple of examples. When we built Sidra initially, there was no Databricks, there was no Spark. The only thing we had for big data was Hadoop, was HT Insight with his Azure's flavor of Hadoop. Brilliant product back then, but well, when the new systems like Databricks came into place, obviously we wanted to adapt to that. But that presents a challenge. You don't want to create a new platform. You don't want to force your users, whether they are different customers, different departments, or just users from your department, you don't want to force them to reload all their data, nor you want to do it yourself. So we created a new piece, a new Databricks for our DSUs, which we will talk a little bit later. And the pipelines just recreated themselves, the ETL process to load the data, and everything was working automatically. Same thing happened when we had to migrate from Data Factory years version 1 to Data Factory version 2, or when we had to change the data catalog solution of some of the customers that want to connect to the data catalog of the platform. So it's very important that we realize the fact that data platforms depend on data products, and data products, they move incredibly fast. The pace of development of new technologies is incredibly fast. So you need to isolate as much as possible everything of your data platform. So we are isolating the management API, we are isolating the data storage units, we are isolating the machine learning model serving capabilities. So everything is different boxes, so we can upgrade some without impacting the rest. So that's really important. Another critical thing was the data intake. We didn't want the data intake to happen manually. We didn't want to provide any kind of UI, neither ours nor of any of the products we work with, and allow the users to, using boxes and lines, create their own ETL processes. The reason why we didn't want that to happen is we know that systems like this depend on being able to ingest reliably and quickly data into the platform. So if there's a new data source with 1,500 tables we need to integrate tomorrow, we need to have them integrated tomorrow. And if these 1,500 tables change for whatever reason in the future, they need to be updated and keep consistent. And we are not going to get that if we need to build manually the pipelines. And if every time something changes, we need to go to the designer, to a graphical designer, and change the boxes and the lines and reconnect, and that for hundreds or thousands of pipelines. That's just too error prone, too difficult to test. So we wanted to rely on something that was based on code. And that's what we did. We basically built a component that connects to the data source, analyze the metadata, whether it's tabular, whether it's binary data, whether it's SharePoint connections, analyzes the data, brings this into a common metadata format, and uses this metadata to create, in our case, data factory pipelines to move the data automatically into the data lake, and also into the business use cases that we will see in a minute. So that was critical for our success. I think that's probably the best decision of the platform in itself, because that allowed us to just change in a couple of bits and pieces, move from HCI side, from Hadoop to Databricks and Spark, move from SQL to Python, and now move to Azure Synapse without having to suffer a tedious and complex and risky migration of ETL pipelines. So that's number one advice and recommendation. I think that was what worked better in all the platform. Also, we wanted to be very, very centric and focus on making sure that once the data is in the data platform, it's immediately accessible to build business cases with it, because it doesn't really make sense to have a data platform just for the sake of having the data. You need to put this data into the hands of the business, and to do that we needed to make sure that if users want to experiment with an exploratory data analysis exercise, or creating some machine learning models, or creating models for BI, semantic models for ClickView, Tableau, or Power BI, they have a means of doing that. But it means that it's not, as most of the proofs of concept we see out there, just spinning up a new subscription of your cloud provider, spinning up some resources, and just doing your proof of concept there or locally in your laptop. You want to ensure that the proof of concept is done in a secure way, in a compliant way, using all the mechanisms we have in the whole data lake, like the same data catalog, the same cost attribution infrastructure, the same audit and lineage tracking, because even if it's a proof of concept, it needs to be done right. And it's also going to make it easier to move the proof of concept into production, because it's just going to be moving from one environment, promoting it to another. So we made a platform, basically we made this concept of the business use cases, which we call the client applications, a first line element of the data lake, that communicate with the data lake and allow the data to be used and consumed. It allowed the data to be transferred and transferred to different data engines like Cosmos DB in graph mode, or DocumentDB, or whatever suits better the use case, or just connect directly to the data lake itself. But also enable this to use the same audit, lineage tracking, all the different shared services that are provided. We think that's important. We think that's important that also when you move into the data governance space, when you want to catalog the data, not just which data you have on the data lake, but which data you have in the data lake that is used by which specific use cases, because maybe you just see immediately that you have entities that have never been used, or there are some entities that are used more than the others, and that's important information. And in this very same line, there are data stewardship and also data governance. There are some requirements that are coming now. There are some GDPR challenges and PCSI and other regulatory frameworks that propose some challenges quite difficult to implement, such as the data archival and retention. I need to make sure that if a customer calls and wants the data to be deleted from our platform, I have a means not just of deleting the data from the data lake and from all the different areas on the data lake, but also to push this deletion to each of the business use cases that use that data, and to track that, and to track if it has been deleted or not. So that's more things that we need to enable as part of the complex. So if you follow me up to this point, you probably see by now that yes, definitely a modern data platform is not just the storage. The storage is just part of it, but we need to talk about the rest of it. How we enable, first of all, how we move the data conveniently, quickly, in a reliant way into this storage, and then how we enable this data to be used by the business and to do it within all these restrictions and frameworks we have to comply with. So the way we built it, again, in this diagram, I think you will see a very brief explanation of it. We have these 4 bits, these 4 elements: ingestion, storage, compute, and orchestration, as part of what we consider to be our data lake storage. There's actually, if we go to the actual details, we have a few more. We have there the knowledge store for document analytics and video analytics and audio analytics. We have also the Kubernetes for storing the machine learning models, etc. But just to simplify, that's our data lake storage, providing the data to the client applications using the shared services. How this is implemented, the data lake? Well, most of our data lakes storage, which we call a DSU, a data storage unit, are implemented like this with Databricks. Back in the day, this compute was edged inside, now it's Databricks, and now we're working on the Azure Synapse bit. And this is one of the modular bits that I mentioned. This is very important, and I strongly encourage you to consider this when building your own data platforms. So, how we move the data in our data lake, in the DSU? First of all, we move it automatically. So we create all the tables where we are storing the data automatically, both the raw table and the optimized table, the optimized storage table. We create the data factory pipelines that orchestrate the movement of the data automatically. We create the queries that checks the validations of data on the tables automatically. And we also create the transfer query that moves the data from raw storage into the optimized storage, that applies the correct partitioning schema, that applies the late arriving data and reloads, delta detection, all that automatically as part of these auto pipelines that are created by the platform. Again, if you get one takeaway from this session today, I would like it to be this. If you are building a platform from scratch, this is probably the best investment of your time and your money. This has been really, really a lifesaver for us. So this means that at the end of the day, we may end up having many client applications, many DSUs. Some of them can be in different regions, in different geographical regions. They are all part of the same data catalog. So if you query the data and you have permissions to see the data storage units and the entities on them, you will see all the data. But they enable these scenarios where you are having geographical restrictions for some of the data, or even if they are in the same geographical region, in the same Azure data center in our case, this enables you to achieve physical isolation. For example, when providing services to multiple enterprises as part of the same group, which by regulatory frameworks, like working with hospitals of the same group, they might need to be isolated. You achieve with this that degree of isolation, which is again critical in some projects. So let's talk a little bit more about the important bit. Once we have the data in the data lake, how we enable that by other client apps. And I'm going to be quite quick on this because we could talk a lot about this integration, but I just want to give you a couple of ideas here. So when we deploy a data lake on our customers, there are many cases. It's not just a data lake where we have, as I said, my data is standing on the storage. and then I power up a Power BI and query that data. That doesn't work. That's not the purpose for the data lake. If that's your only use case, you don't need a data lake. You need a data mart approach. That's it. But when we go for our enterprise customers, normally what we have is a lot of different business cases. So we're working right now with a very large law firm in the UK. They are right now, I think they have in production 20 something client applications, so 20 something use cases from the data lake. So that's providing real business value. And they can be a lot of things. They can be from a small data marts, a client app, a business use case can be one of the data marts we saw at the beginning of the presentation. So we can have one data mart for finance and one data mart for operations. But we can also have a client app which is just a very simple machine learning model to predict liability or to predict customer churn that it's not even connecting in real time to the data lake, just using it to train the model. Or we can have even a full-blown web page, a mobile application connected to the data lake as a client app. You can have anything that makes sense for the business as long as it shares some principles on identity, on lineage tracking, security, compliance, cost attribution, these kind of details. In our case, some of the out-of-the-box things that we always implement in our customers are the data lab and the data labs client app, which is a separate cluster, which is normally powered by Databricks, to enable sandboxes for data scientists experimentation. We don't allow normally the users to go to the same cluster we use for the loads and ingestion of data, for the intake, or the data quality cluster, because that would jeopardize the time. If we have our data scientists using the clusters too heavily, that could make at risk the timely delivery of the pipelines of bringing the data into the platform. So we have this isolated into one infrastructure we call the data labs for model building, exploratory data analysis and such. And we have one which is super important. This is one of the other good ideas we had. If I have to give you a list of the things to copy from us, this will be one of them, which is the integration hub. We wanted to make sure that the data lake was, again, something that provide value to the business. It's not just storing the data, it's being able to provide this value. And you're not going to just provide value if all the changes or everything that happens as part of the data state of the company is only stored in the data lake or is only done in a reactive way. So we created something which is the integration hub, which is basically a fancy name for an API on top of a message bus, in our case Azure Event Hub. So we can create several topics, one for each client application, and several system topics. So for example, we have data archival and retention topic. We can publish every time we delete a record from the data lake, from a DSU. We can also publish that deletion message into the service bus. So all the client applications like Power BI dashboards, like machine learning models, or even not client applications, but external systems like a case management tool, like a CRM, like your Dynamics, Salesforce, whatever, can listen to that, can take note of the payload of the ID and delete the entity on their system as well. So we can use this as well as a mechanism to distribute messages and broadcast this information across all the platform. So another example, I have an application which is a web or mobile application, which our end users can change their profile data, and they change their telephone number. So this data can reach the integration hub automatically, and any client, including the data lake itself, can be registered, and using Delta storage, which is the new feature I'm going to be talking in a minute, can update the data automatically. This is more or less, it's not exactly, but it's more or less applying an event sourcing pattern to a data lake approach. And again, this is one of the ideas I will really love you to copy from us, because this one has worked really well. So let's talk about the road ahead. Let's talk about what's coming and what are the changes. Well, first of all, data lakes have a set of challenges. I'm seeing this very often because I do a lot of consulting work and professional services work. So first of all, deployment complexity, we have already talked about that. So again, we really recommend them to be modular and obviously auto-deployable. If you're using ARM templates or Terraform, that's a good first step. Obviously, deploying everything with proper DevOps processes, that's a good second step. If you can automate this even more, go for it. It's going to be a time saver. They also have challenges with real-time and Lambda architectures. What I mean with challenges with real-time? Well, we have been working with data lakes with real-time data for a long time. And they work well. We have a pattern which is called the Lambda architecture. I briefly touched upon it some minutes ago, in which when I need to react to real-time data, I can just create out of my consumer, my Kafka or my message bus of choice, I can just define two outputs. One output is going to pass the data without any transformation to my dashboard, to my client application, whether I'm doing a specific IoT computations or whether I'm presenting it on a Grafana dashboard, whatever. And then I have another output which is going to pass through some validations, and it's going to be integrated into the data lake, maybe in an hourly fashion, maybe in a daily fashion, but it will allow me at some point in time to use this for my BI processes. And that works well, but that requires duplicating validation rules, that requires duplicating a lot of things. If you follow an approach like we use on Sidra, that's a little bit less of a concern, because this duplication really is not that error prone, because we are generating the pipelines automatically. So we generate this automatically. So that's not really that much of a challenge. But you need to duplicate a lot of things. So it's far from ideal. But we also have other challenges more based around reprocessing, how to tackle multiple terabytes tables or even petabytes table, where I need to reload it because some rule change, some validations change, and I need to pass a process from scratch when maybe I know it's only probably going to affect the last 100 partitions and not just the whole data set. So there are some challenges there. And there are a lot of challenges around updating data, merging data. Again, I mentioned the right to be forgotten. How do I work if my tables are immutable? How do I work on my tables to delete a specific record, especially when the table is large? So I needed to resort to copy this data to other tables, rename it, move it back. There were mechanisms to do that, but that required dedicating a lot of investment in times, potential points of failure, increasing our surface area, just for things that should work out of the box. So the good news is that Databricks presented the Delta Lake. Delta Lake is the Delta Engine. Actually, it's the name. Delta Engine is a mechanism that allows our tables in the data lake to have full ACID transactions. So that means, well, you know, the acronym for atomicity, consistency, isolation, and durability. Basically, what this means is that now I can just do inserts, delete, merge, and work with the data almost as if it was a traditional SQL Server database. Does this mean that we can use now a data lake as an operational data lake? No, I wouldn't go that route. Why? Because there's still a lot of a large payload for the operations. I'm not going to get into these details in this session because I don't want to go to the technological implementation. But in a nutshell, using Delta means that there is a slight trade-off, a slight overhead in terms of performance incurred by the journaling that it does, by how it keeps a transaction log itself. And that means that all the queries, they get something between 30 seconds to 2 minutes additional time. So it's not for real-time queries, really. It's for near real-time or for this kind of scenarios where we can lift it with this kind of times. But for large tables, this is a game changer. This is massive. It's based on Parquet, on the Parquet format. There is no technical limitation why this will not work with other formats like ORC, even though they are not opening that bit yet. But if you're using Parquet, it will work with it as such. It has been recently, some 2 or 3 months ago, released into open source. That means that you can use it even if you are not using Databricks distribution, but if you have your Spark cluster, you can use it. And it's, again, really game changer. Internally in Sidra, we have fully adopted. Up until now, our customers can choose the storage format for the tables between ORC, Parquet, Delta. But we have taken the decision that we are just going, in the next version, we are just going to support Delta. It doesn't make sense not to have it by default. So amazing functionality here. It allows you to build, this is entirely optional, how you want to lay to lay your data and your strategy, but it enables scenarios such as creating bronze tables, silver tables, gold tables. So bronze are just raw data, a lot of quality issues. They just ingest it in as quickly as possible and the way they are, and then they are refined, and then we create the business level aggregates on top of them. So again, very interesting approach to storage on data lakes. So the next step that we are hearing a lot right now is the data lakehouse. Data lakehouse, and I point you here on these slides. This is a very nice diagram by the Databricks team. Data lakehouse is basically providing on top of a data lake what they call a transactional layer. And this transactional layer, as you probably have guessed by now, is precisely the Delta engine. The idea is that we are using the same mechanisms that we are using to bring data into the data lake, but then instead of having ETLs to move the data towards the client applications or the specific business use cases, we just allow different queries to be defined on top of this transactional data. This goes hand by hand also with the Photon engine and the SQL Analytics product that has been announced just a couple of weeks ago, which is again going to be a little bit of a game changer for the data lake world. So if you made it this far, I'm quite sure that's because you're really interested in the topic, and probably you're considering building a new platform yourself, or you're just in the middle of considering upgrading yours. So let me share a couple of things with you. Let me share first what I think we really did good, we really did well, and I think it merits to be replicated. And on that list, number one for sure is making sure that you create the pipelines with a metadata driven system. So create them programmatically, not graphically. It has been the single most important thing we've done, and really lifesaver many times. Secondly, I would like to refresh back to the modular architecture. I think that's critical, ensuring that you can upgrade your platform, because you will need to upgrade your platform to the new tools, to the new techniques, to the new technologies, and that doesn't impact the rest of the system. So that's also very important. I think also the integration hub is something that has a lot of merit, making sure that in some way or another we can implement some observability and some kind of event sourcing approach to our data platforms. That's also key. There are many other things we could talk, things that weren't well, but let me focus now on what we didn't get quite right. And the two of them are basically the same thing. Actually, the three of them are very, very much related. When we built the platform, we had this data strategy side by side with the platform. And the data strategy was a 2-tier data storage unit plus business transformations at the client level, at the client application level. That means that the data gets into the raw storage without any transformation. moves automatically to the optimized storage, just with technical transformations, no business transformations of any kind, and then moves to the client applications when the business application take place. But that means that for even basic data quality processes, we needed to move them to a client application. We had a client application, and we still have, which is a data quality client application, which does the transformations and brings just back the data. That's good from a lineage tracking point of view and from an audit point of view. That's great from a governance point of view, but that's not so good in terms of time to have the data ready. And well, it's a little bit cumbersome, and that's something that very recently we decided we are going to be changing, and we are going to, using Delta tables, we are going to do the transformations as part of the DSU themselves. The same applies to our master data solution. We have a master data client application, which is going to be integrated as well into the core, because data quality and data mastering really should be part of the core and not of the client applications. And also, we were kind of hesitant of moving to a 3-tier approach, a bronze, silver, gold approach, but in line with this data quality and master data processes, we are also going to be considering that for the future release, for the next release of our data platform. So that's some of the things that I think didn't work well with the platform, and we wanted to share with you. So, well, you take also our learnings here. And that's what I wanted to share. We've done quite a little bit of a journey. We have gone through the prehistoric age. We have gone through the data warehousing and data marts, and we've talked about data lakes a lot. We've talked about the new developments on data lakes and what's Delta Lake and what's the data Lakehouse. So I really hope you have got some useful information from this. If you have any questions, doubts, comments, please reach me on Twitter. You have my Twitter handle. And again, thanks for being part of Singularity, and thanks for watching this session. Talk to you. Cheers.